Hello, everyone. You are welcome to this lesson. And in today's lesson, we are going to continue from where we left off. We are looking at functions and core math aspects of what functions. That's not to say it is strictly in core math. You can also get it in native math as well. Okay. And in our previous lesson, which was lesson 3, we were looking at how to find the value or values of x for which a relation or a function will be undefined or not defined. Okay, so today we are going to look at what's lesson 4. And lesson 4 of functions, like I said, will continue from where we left off in lesson 3. Okay, I'm Mr. Hackman and I'm going to be your facilitator. Okay. In our previous lesson, just as I mentioned, we realized that anytime you are asked to find, okay, the value or values of x for which a function or a relation is not defined or is undefined, okay, we just set our denominator function or expression 0 and solve the resultant equation. The resultant equation could be linear, it could be quadratic. That's where we ended. Okay, possibly today we'll look at a situation where it will be cubic. It's the same understanding that we extend to the cubic situation. Okay, when your resultant equation is a cubic equation, how then do you deal with it? No worries. Okay, by the end of today's lesson, we'll be able to deal with that. Okay, so quickly you can see, okay, on your screens, we have what question number 3. We've done questions 1 and 2. So let's look at question 3 that we have here. Okay, now we are supposed to find the value or values of s for which, okay, the following relations or functions are undefined. So these are the given relations, okay, or functions. So let's go and look at how best to present our solution. And again, please take notes. Please take notes. Your presentation really, really matters. It is not your understanding alone that can give you the A1. Your presentation, okay, must, okay, complement that for you to get what your A1. So you be mindful in terms of how I present my solution. You try to adjust, especially if I tell you don't do this, do that, or I do something and I ask you, okay, what I've done, is it correct or is it wrong? Okay, once you are able to correct me if it is wrong, then you have no business not to correct yourself. Okay, when okay the need be. So now this is what we have. And we said, okay, this situation that we are dealing with, we said any question that you are given, provided the question is numbered, your solution must also be numbered. And you must always avoid introducing your own numbers. If the question is not numbered, okay, it's not by force for us to number questions. And it's not by force for you to number solution if the question is not what's numbered. Remember, I said you number precisely. Precisely means appropriately and what accordingly. So here, no question, okay, number, therefore no solution. Oh, sorry, question number is 3, forgive me. So it means the first thing that you write is solution, then you write the question number. By then, I've told you, you read the question and you underline the salient part. So having read the question, okay, we know that we are supposed to underline undefined, because we need to make use of what this keyword that we have there. But the function that we are supposed to find, okay, the value or values of x, for which it will be undefined, we need to extract that function. So we come to A. Okay, there is no major information to extract here. So you come to the sub, okay, question number A. And question number A, we extract function that we need to find, the values that will make it undefined. So in this case, given what's the name of the function came in the relation form. So you equally extract it as such. So h of x is equal to x plus 1 all over what? X squared. Okay, plus what? 4x plus 4. All right. But we know, we said after extraction, what do? We have to go and write, okay, for undefined, we state the condition for that. So for undefined, and we use the exact, okay, word there. Remember what I told you in our previous meeting. our denominator function should be equal to 0. So what's your denominator function? S squared plus 4x, okay, plus 4. And that should be equal to 0. So now if you look at, okay, the resultant equation coming from setting your denominator expression function to 0, okay, you can see that you are dealing with a quadratic equation. So at this point, you ask yourself, how do I solve quadratic equations? Like I mentioned in our previous meeting, you have three, okay, ways or method of finding. In actual fact, you have four. Fourth one would be graphical approach. We usually don't talk about that, okay, unless maybe you are supposed to use your graph. So we resort to the first three, which will be factorization, completing a square, or the quadratic formula. But we said the convenient one would be the factorization, only that it's not all equations that would be solved by what? Factorization. But if your quadratic expression is factorable, it means your equation, okay, is solvable by factorization. Sort that. It's when factorization fails that you use either the completing of squares method or the quadratic formula, okay, to deal with it. But when the factorization method fails, please remember I told you, between the other two, completing of squared and the quadratic formula, please use the quadratic formula, because you know basically formulas are supposed to make our work very easy. So at this point, we are going to solve this quadratic equation. And thankfully, the leading coefficient is 1, which is the coefficient of the s squared is 1. So you multiply 1 and the 4, and that will give you what? 4. Or immediately you realize that the coefficient is 1, just come and take your c, which is what's the 4, because this is as squared plus bs plus c. Okay, so in this case, your C is 4. So you look for factors of 4, okay, which when you factor pair, when you add, you get 4, and when you multiply, you still get 4. You get the coefficient of x here when you add. So what factors come to mind?
Two.
Okay, which factors? I said 2 factors, so you mentioned only one.
2 and 2.
Okay, 2 and 2. Positive 2 and positive 2 and 2, very good. So you use these two factor pair. Okay, you use that one to split this. Okay, so this is what we are going to do. We are going to get what? You can write this implies that, because you know at this point you are dealing with an equation. So this implies that your s squared, take note, then this one will be split using the factors 2 and 2. So it will be plus 2, one of the factors, then you attach x, then plus the other factor, which is also 2, then you attach x, then plus what? 4 is equal to 0. You can see that you should obviously know that what you have here is the same as this, only that this is broken down into 2 based on a certain condition. So if you add this, you get exactly what is here. So you have not changed the equation. We are working with the exact equation. So at this point, remember I told you, you have to group first two and last two. Okay, so factorize group in such a way that each two sum will have common factor. So first two, last two, but when you are grouping, you don't introduce bracket two. I told you it will be costly, and I explained why. And you all admitted that it will be costly. So we are going to move away from using bracket two. So we group mentally. So I group the first two, okay, and factorize. So if I'm factorizing, I check if there is any common number apart from one that I can bring out. No, any common variable, yes, so I can bring s out. Okay, then I'll be left with what? X plus 2. Yeah. Then with this one too, okay, I can bring any common number that I can bring out. The last 2 years, the common number is 2. Yeah, I can't bring any variable. It's only 2 that I can have to X plus 2. Okay, is equal to 0. Is my point well made?
Yes, please.
Okay, so no, you know that at this point we are going to get x plus 2, okay, into x plus 2 is equal to 0. And remember, okay, we said whenever you have the product of two numbers giving you 0 or even 3, giving you 0, it means at least, okay, one will be 0. So you just set each of the factors to 0 and you solve. So it means I'm going to get x plus 2 is equal to 0. Or remember the connector, or don't use capital, just use small letters. That's okay. All right. So one of you use this, I underline. That's not to say that you are wrong, only that the correct thing is this. Okay. So now, if you continue, we are going to, have the other one also to be x plus 2 to be equal to 0. So x plus 2 to be equal to 0, which gives us x is equal to -2 here, and x is equal to -2 here. And you can see that always, after forming my equations, I solve below. Okay, making sure that nothing interferes with it. Other than that, each step on the way, when you are solving, you have to come and write all. Okay, when you are solving this one, to come here in all. But to save time, nothing interferes with this. So it means the all is simply understood to be there. Okay, it's the same concept. When you are solving an equation or maybe an expression, you are simplifying and you write the expression and you come and write equal to. You can see that the equal to here is affected by the expression up there, equal to. So because you don't want to keep on repeating the expressions, that's the more reason why he said usually make your equal to be in line so that your expression up there simply be understood to be there. So exactly the same meaning. So now here you draw your conclusion. Okay, therefore x is equal to, you can see that we have repeated values for x. In this case, repeated solution. So what do we do? I said whenever you have this, you should discard one. You should only write one. So that will give us -2. Okay, so you draw your conclusion. You cannot write therefore x is equal to -2 or -2. You can see that obviously doesn't what proper sense. Is my point well made, my professors?
Yes, please.
And
Yes,
like
please.
I told you, no, it is not your duty. Okay, once you know you are doing the right thing, okay, it's not your duty to verify, or it's not necessary. Let me put it that way. Verify whether this is the x value that makes your function undefined. But let's go and verify. Okay, so if you put -2 there, so it means I'm going to get -2 in bracket squared. Okay, then plus 4 into -2, then plus 4. And which will give us what? I'm more interested in the denominator because it's the denominator that we are saying if you substitute, you should get 0 for it to be undefined. So I will get 4, then -8, then plus 4, which obviously is 0. So indeed, if you substitute x is equal to -2, your denominator will be 0. So this is the x that will make the function undefined, the value of x. Is that clear?
Yes, please.
Okay, wonderful. Okay, all right, we will move on. Remember, I said today we are going to solve 4 questions on the quadratic and maybe move on to the cube. Okay, another 12 questions very soon. Okay, so if you don't have any questions, then I guess we can move on. All right. So those of you, if you understand perfectly, that's why you have the questions here. Okay, you can move on to the next one. And as we do it, you cross-check with your solution and see if you did the right thing. Okay, all right. Okay, so now we move on to B. And remember, you don't leave any spaces between your steps. Okay, so as for these, low-hanging or simple advice, adhering to it should be very easy. Okay, it doesn't need thinking. You just have to know that don't leave spaces between your steps. That's all. Okay, and I think yesterday I told you that I will share, what do you call it? The constraint paper for you. Okay, to see the more reason why I said you should. Someone sent me a constraint, paper. Someone yesterday did that. Okay, but unfortunately, I think, let me see. Is it Atto? Yeah, it should be Atto. So I'm sending it to the platform. Please, take note. That will be the nature of the constraint paper. So I will speak to it during the break. Okay, so this is the constraint paper. Let me pause then maybe do that quickly before I forget to escape. Okay, so now we move on to B. Okay, B, we've been given a function, and the name of the function is what? G of x. Okay, so G of x. Okay, please let me erase. It seems the sensitivity of my pen is to a new level now. Okay, so I think I can manage. So let's manage. Okay, what do we have? G of x. Okay, and G of x we are told is what? 4x minus 2 all over 2x squared minus 5x, then minus 3. Okay, so you know what to write. For undefined, okay, your denominator, which is 2x squared minus 5x minus 3 should be equal to 0. Take note of that. Okay, so at this point, the video that I sent you, I believe you should all, especially those who had issues with that. Okay, so I am going to continue. So at this point, I'll write this implies that, okay, I am going to factorize this. Okay, this is a quadratic equation. So I'll first of all check whether the quadratic expression is factorable. If it's factorable, then the best method is the factorization method to solve. So now, here, unfortunately, the leading coefficient is not 1. So we have to multiply this by this, which will give us was -6. So we are supposed to look for factor pair of -6, which when you multiply, you get -6. And when you add, you get the coefficient here, which is -5. So that will be the two conditions that your factor pair must satisfy. Hello?
Hi.
Hey, hand is up, Benedicta, Prof. Benedicta. You want to give us the factor pair, I guess. So go ahead. Prof. Benet, your hand is up. Wow. Okay, so I don't know whether, okay, so Prof, yeah, what's right? Let's go. What factor
6
pair?
and -6 and +1.
Good. Okay, so you corrected yourself. -6 and what? +1. Please take note. Anytime your that gives you negative and you are looking for a factor pair, the factor pair, one of them must be negative. So immediately you settled on what? Let's say you have 6 and 1. But these two factors, one of them should be negative. So it's either 1 is negative or 6 is negative. I realize that if 1 is negative, 6 being positive, you add, your result will be what? Will be positive. So here we want the result, the addition result to be negative. So it means the bigger of the two factors must take the negative. That's why between the 6 and what 1, we attach what? Negative in terms of finding the factor pair. So that when you add, that's -5. But in this case, you use the two factor pair to, okay, what do you call it? Or the factor pair to split, okay, the middle number that you have, or the middle term. So we are going to get 2s squared. Okay, then the factors you said it will be -6 and +1. So I'm going to write -6, then I attach my x. Then what? Plus what? 1x, but I won't write the 1. It's simply understood. Then your last term is -3, and it's equal to 0. Don't forget. Because you are dealing with equation. Every step on the way, you should be dealing with an equation. Okay, so yeah, you can put down your hand unless maybe you want to ask a question or you want to make a contribution. It's not the whole plan. Okay, thank you. So at this point, you group first two, last two, and factorize. If you group the first two, and anytime you are factorizing, ask yourself, do I have a common number that I can bring out, which is common numerical factor? Do I have a common variable or variables that I can bring out, which is common variable factor? Okay, so here I do have between these two, I have a common factor. 2 and what? And 6. Okay, I can bring out 2. And the variable x is so common to, so I can bring that one out. Okay, the x with its power. And now factor out 2. 1 factor 2. So I'll get x here, then minus what? This will give you array. Remember, if you want to get the terms in brackets, I said you divide each of the terms, okay, that you are factorizing and you factor out, test out. You divide it by 2x and that will be the 2 terms in brackets. Then plus this one, you can't factor anything out apart from 1. Okay, then have your x minus 3 also that's equal to 0. Okay, so at this point, you get x plus 1 into x minus 3 equal to 0. So our comfort zone now, product of 2 factors, numbers 0 is, okay, at least one of the numbers should be 0. So you set each of the factors, okay, here, okay, to 0. And, okay, you solve for x. So you can see that here with this one, it's very easy to solve for the x. So I will come in this one first. So x got here. Then here it will involve a little more work. I will take note. So I'm going to have x, then it's equal to, I move this one side, -1. I write it again before I divide, take notes. Okay, so over 2, over 2. So I will get my x here to equal to -1. So at this point, I'm in a comfortable lead. I know my s value, so I can draw my conclusion. Therefore, x is equal to, okay, -1 on 2 or 3. Is my point well made?
Yes, please.
Okay, great, wonderful.
Yes.
All right, okay, so at this point, obviously, okay, C is not available for me. And any question that you see in green, now any question in red, okay, likely to assignment. Let's maybe I change my mind. But any question in green, take note. It means likely you will see it in your class test. So make sure you practice or you look for the solution for it. Okay, all right. So let's go to the last question for all of us, which will be what's next. Okay. Okay, D, what are we giving? We've been given a function, but the function came in which form?
In a mapping form.
In the mapping form. Very good. And remember we said, okay, we avoid extracting functions in this form, mapping form. So you extract it in its corresponding relation form. Please take notes. Unfortunately, yesterday, the assignment, some of you made the wrong thing. You extracted functions in arrow form or mapping form. So this will give us f of x is equal to the corresponding relation form. And that will give us 3x over, okay, 2x squared, okay, minus 6x. Okay, so we are still looking for undefined. So for undefined, okay, your denominator function, which is 2x squared minus 6x, was 0. So as for this one, we all get, okay, this particular step. I've told you, the fact that you see a big space here doesn't mean I'm not working with lines. So I haven't left any line of the unattended to. I'm working with lines, so please take note of that. Don't leave any line unattended to. I will keep on stressing on that until I realize that all of you are right. Okay, so at this point, we are dealing with an equation again, and that equation is a quadratic equation. So the highest, okay, power of the variable there is 2. Okay, so making it quadratic, not a linear one, not cubic. And we know for every quadratic equation, our first method of solving it, that will resort to, okay, will be the factorization method. So we'll check whether quadratic expression that we have there is factorable. Once it's factorable, then it means we can use the method of factorization to solve. So in this case, obviously, this quadratic expression is factorable. So if you want to factorize Okay, here there is no constant term. Okay, for you to come and say multiply this one by this, and in that case, because usually there's a constant term, you won't get any term, okay, or any factor common to all the terms, be it numerical or variable. Okay, so otherwise, anytime you are factorizing, the first question you ask yourself, do I have a common numerical factor that I can bring out, a common variable factor that I can bring out? And we ask ourselves that situation. So a common numerical factor that we can also bring out, a common variable factor s that we can also bring out x. Is my point well made?
Yes, please.
Okay.
Yes,
All right.
please.
Then have factorized, okay, the number, okay, and the variable factor. Okay, so you bring your bracket. So if you want to know, because you have two terms here, is you are going to get two terms in bracket here. But how do I get the two terms? Take each of the terms here and divide by what you out. So 2s squared divided by 2 as a cancel. The s will cancel one of the x left with x here. Then minus, okay, 6x over 2x, you know, 6x over 2x. Okay, x will cancel 2 here, 3. So you'll be left with what, 3, and it's equal to 0. Let me equally explain that of the 2s squared over the 2x. Okay, this will cancel one of that, so you'll be left with x. So that's how come you have the s here. But you can always do this mentally. This is not necessary. Okay, so at this point, you know, okay, indirectly, you have three factors. Okay, you have the factor 2, the factor x, and all of this. Okay, so that is what you are supposed to do. Okay, take note. But you know, remember we said, anytime you are with factors, be it more than a factor, okay, I mean more than two factors, okay, you use a zero product. Once the factors, by equating it to 0, you use a zero product rule. Please take note. Okay, all right. So at this point, this is what we are going to, okay, do. Okay, so instead of equating, because if you come and write equal to 0, doesn't make sense. Obviously, 2 is not equal to 0, is that not it? So though you have three factors, okay, when you are equating your factors to 0, if the factor is a constant, okay, don't consider that. So consider the variable, or this is an equation. Once it's an equation, you can reduce that, and you can reduce that by dividing 2 by 2. So somebody can divide this 2 by 2, okay, and the person will get x into x minus 3 is equal to 0. But this is what we are going to treat the whole of this constant and this variable as one factor. So in this case, instead of writing, I'll write 2x is equal to 0, or x minus 3 is equal to 0. Should I come again?
Yes, please.
Okay.
Yes, please.
All right. Remember we said if you have, okay, let me write it here. A and B is equal to 0. A will be equal to 0, or B will be equal to 0. If you have A, B, C to be equal to 0, it means A is equal to 0, B is equal to 0, or C is equal to 0. Take note. However, anytime I have a constant, so let's say if I have, okay, 2A is equal to 0, what do? Won't you divide by 2 and divide by 2? Or I cannot write, I have two factors. So I can say that 2 is equal to 0, or A is equal to 0. Okay, you can see that the first one, 2 is equal to 0, is not making sense. Obviously, 2 is not 0. Okay, so for the whole of this to be 0, it is rather this that you concentrate, because these two, okay, the other factor is not 0. So it means if the product here would be 0, the A rather must be 0. Okay, your first factor cannot be 0 because it's not 0. So you only equate the variable factors to 0 and you solve. Don't equate the constant factor to 0. That's my point. That's a constant factor. Can you see that? 2 is a constant factor. S is a variable factor. S minus 3 is a variable. I said, you can equally deal with it the way we've been dealing with it. I have a constant and a variable, so I can treat the whole of this as a factor. Okay, the whole of this as a factor. So it means once I have a constant and a variable, so if I have x, this is a variable. If I have 2x, is it a variable or is it a constant? So any expression that involves the variable only becomes a variable expression, variable. You get the point? So it means if I'm considering the whole of this as a variable, it's allowed. So my variable here has been equated to 0, and this is my second variable, which is the second factor, and x minus 3 will be equal to 0. So any expression involving a variable will be a variable expression, and we have to use it for 0. In this case, a variable factor. So what do we do here? We are solving for x. In each of them, x is not solved. So you can write it again and divide by 2. But this is a special situation. Written, okay, x is equal to 0 straight away. But 0 over any number will give you 0. However, x will be equal to what? 3. So in this case, what will be our conclusion? Therefore, x is equal to 0 or 3. Is my point well made? Those of you who said I should go over, are you fine now?
Yes, please.
Yes, sir.
Very good. So I'm saying that the point here that you are supposed to get, anytime you have a constant multiplying a variable, okay, and you want to use the 0 product rule, consider the constant and the variable as one factor and work with it. Okay, someone who is smart, okay, will straight away, I know that I will not consider. So in this case, okay, if you are smart, as you move on and as you mature, if anytime I have maybe 3x, okay, into maybe x plus 1 equal to 0, I know that, frankly speaking, I'm dealing with 3 factors. Okay, 1 constant factor and 2 variable factors. One of the 2 variable factors would be x or is x. The other variable factor is x plus 1. So I said, when you are using the 0 product, you put the constant factor to deal with the variable factor. So here straight away, instead of writing 3x is equal to that, I'm mature. So I'll write x is equal to 0 or x plus 1 is equal to 0. This one, x is solved for, so I'll get x equal to -1. So it means I could have done the same thing here. I could have written, because I know this is a constant factor, this is a variable factor. To need the variable factors, that I must, I'm showing my. So I will write my first variable factor, s is equal to 0. My second variable factor, or x minus 3 is equal to 0. This one, x is solved for already. So s will be equal to 3. Wouldn't I draw the same conclusion? You get the point? Is my point well made?
Yes.
Very well made.
Yes, sir.
Okay, great. All right. Okay, so at this point, this is what we are going to do. So I'm going to clear this, and I think we are done. It's okay. The question for me, this particular question number 3. So I'm done with you. We are going to look at another nature of questions that you have to find the value or values of x for which your function can be defined. Let's look at the nature of such questions. Not pretty at all. Okay, but don't worry, you are more than capable of dealing with this. Just 1 or 2 information that I have to provide. Once you get it, okay, you are good to go, or you should be good to go. So again, find the value, okay, or values of s for which the following relations or functions are not defined. So it means when we are reading the question, the underline that's not defined. Okay, then we have the given relations and what functions. Okay, so again, this one is not available, okay, for me. If only this one is not available for me, you do it as a classwork, very likely. Okay, so we are going to do the first one together. Okay, so quickly, let's see how to deal with questions of this nature. As usual, okay, if for nothing at all, we know how to start out. And I'm so sure, okay, that for most of you, if not all of you, you realize that okay, you are appreciating your presentation. Okay, some of you, you've adapted very fast, and I like that. Okay, those of you who are yet to adapt fully, please consciously do that, okay, quickly, so that I know that we are all at the same level, and I will be very comfortable to, okay, know that. So now, what do we have? The questions are numbered because we want our solution to be numbered. So we have question number 4. Okay, so we number our solution as well. Solution is what you write first, especially those who write questions. If you don't write solution and you proceed straight away, I wouldn't be able to distinguish between your questions and what and your solution. So take notes. All right. Okay, so now, okay, I don't have any major information to extract here. So I come to my minor question number A. Okay, and I extract the function. Okay, what are we giving? We are giving f of x is equal to 1 over x. Okay, then plus what? 2x over, okay, x plus. Okay, so you can see that so far, okay, we've been dealing with only a single rational function. A single rational function that says that, okay, if you go back, which let's go back and see just one. Okay, so, okay, this question, you can see that this is a rational function, it's a single rational function, a single fraction, a single fraction, a single fraction, a single fraction. If you look at what we are confronted with here, okay, we have more than, okay, a single fraction. This is a fraction, this is a fraction, so we are dealing with partial fraction. You should know every partial fraction can express it as what? As a single fraction. Just as every partial, okay, maybe fractions. Let me see if I have 1 over 2 plus 1 over 3. I can always write this as a single fraction. And what that's my LCM is equal to times 3. Okay, then I just go here 3 times 1, so 3. Then plus this will go here 2. So I can always write this as a single fraction. And by so doing, I've taken it to my comfort zone because I know how to deal with single fractions. Okay, how to find undefined when the function is a single fraction, but I don't know when it is a partial fraction. That's my point. I hope my point is well made.
Come again.
Okay, so I said, okay, if you look at the nature of question where we are coming from, you realize that, okay, all the situation, the function that you are asked to find undefined values of x, or the values of x that will be undefined. Okay, you realize that it's only a single fraction. Maybe it is only this fraction or only this fraction. We never had, okay, the addition of 2 fractions or the subtraction of 2 fractions. You get the point?
Yes, please.
So here is the case we are confronted with such. I'm saying that always, okay, because you know how to express, okay, more than a fraction, meaning partial fraction as a single fraction, you can take the question to your comfort zone, which is a single fraction one, and work with it. So that's going to be my first advice. Now, as you mature, I will tell you how to proceed straight away without stress or with little stress. That's my point well made.
Yes, please.
Okay, so for now, we know that this fraction or this function that we are giving there is not in the form that we like. It's not that, okay, the single fraction. So what do I do? I'm going to express it as a single fraction. Keep it to my comfort zone because I know how to find undefined or single fraction. I'll go and write this is equal to. So I'm taking the LCM. You can see that as I am writing, next I came close to the margin because I want to create room here for my rough work. Never do your rough work here. Take notes. Okay. So at this point, I'm going to take the LCM. What will be the LCM of x and s plus 4? It will be x, okay, into s plus 4. Do you get it? Is that clear?
Yes.
Okay, you remember
Yes.
GHS. Okay. All right. So now you ask yourself, x will go into s into s plus 4 how many times? It's like you have x into s plus 4 divided by x. So x will cancel. So I'll be left with s plus 4. So it will be s plus 4 times 1, which will give me s plus 4. Is my point well made?
Yes.
Okay, then plus.
Sir, please come again.
I should come again. Okay, all right. It's just like whenever you are expressing, okay, fractions, more than a fraction, okay, or 2 or more fractions as a single fraction. That's as we did over here. Okay, in terms of your comfort zone, you take the LCM, and the LCM always will be this times that. Okay, usually it will be this time that, provided this is not a factor of that. Okay, then you multiply. If there's a factor of that, then you have to go for the LCM. Okay, so in this case, if you multiply this and this, that will give us the 6. So it's the same thing that we did here. We are taking the LCM, we are writing this as a single fraction. And anytime you want to write fractions as a single fraction, it calls for LCM. Exactly. Immediately you take the LCM, and it means you are going looking for a single fraction. So you ask yourself, so what will be my denominator? My LCM is times that. So just keep it in terms of factors. So x times s plus 4. And because s plus 4 is more than a term, that's why I put it in bracket. X2, you can put it in bracket, but it's not necessary, but it's just a term. Okay. Then what do you do? When you took the LCM, what did you do? You ask yourself, these two, okay, how much, okay, will it go into what? How many times will it go into 6? And how do you find, okay, the number of times 2 go into 6? It will be 6 divided by 2. I hope you get it. Which gives you 3. So it will be your 3, then you multiply it by 1, which will give you 3. Then again, you come and do same for this denominator. So it will be 3 going to 6 how many times? So it will be 6 divided by 3, and that will give 2 and times the 1 here. So the same concept that I am extending to this. Okay, my LCM is s plus this. So if I want to know, okay, the number of times s goes into my LCM, it will be the whole of this divided by s, and the s will cancel. So I'll be left with s plus 4. Okay, and always you want to know, once you multiply, even without thinking, you want to know the number of times it goes into. Keep this one out, write the other factor. That will give you the number of times it will be times 1. So it should have been 1 times this, but I know that 1 times this will always be 1. So I don't have to write the 1 bracket this. Okay, then plus, okay, you ask yourself the number of times s plus 4 go into your LCM, which is s plus 4. And that one, so x plus 4 all over s plus 4. You want to know the number of times s plus 4 go into that. So the s plus 4 will cancel this. So s plus 4 will go into s times. Come and write x. So it will be 2, okay, x, then times the number of times that is x, or s times x. I guess my point is well made. Now, okay, so now if that's the case, then here we could have written the answer straight away. Okay, but because, okay, some of you were not getting it, okay, I have to write it this way. So otherwise, I would have written this. Now, this is equal to, I think. Okay, so at this point, you've been able to express this as a single fraction. So it's like now you've been given f of x is equal to this, a single fraction. Okay, so how then do you find the zero? So you come and write for the zeros. So now I'll write for the zeros. Oh, sorry, did I say 0 for undefined? Forgive me. Oh, it's not defined. Not defined instead. Remember, we go for what is provided in the question. So let me clear that and clear all that I would. So this will go. I wouldn't need this. Okay, so those of you with issues writing, okay, expressions as a single fraction, okay, let me know. Maybe I will send you a video on that one too. Okay. So I have not defined. Okay, your denominator, what's your denominator? X into x plus 4 should be equal to 0. So now our comfort zone. Okay, so it means x should be equal to 0, or, okay, x plus 4 should be equal to 0. So you have to equate each of the variable factors to 0. Please take notes. Don't be partial. In your previous assignment, when some of you had this, you only worked on this particular factor. Okay, please, this one is also a factor. You should equate it to 0. So that gives you x is equal to minus 4 here. Here, s is already solved for. So you draw your conclusion. Therefore, x will be equal to 0 or minus 4. Is my point well made?
Yes.
Yes.
Okay. However, okay, please, this is how I would want you to go. Don't stress yourself, especially those with this issue. Okay, this is all that you are supposed to do. Okay, and your work will be very, very easy. So we are going to look at an alternative method. Remember, I said this alternative method should be the way to go. Okay, so we are going to start again. We will extract. So what do? We write giving. So your question number. So let me assume, okay, we have this. Then you extract. So giving, what are we giving? F of x. Okay, the function came in the relation form. You thank God. Okay, so you extract it in the same form. Okay, this is so straight away, you can come and write for undefined without writing it as a single fraction. Take note. So, oh, sorry, not defined. Remember, we said we have to use. Okay, so not defined. This is what you do. Okay, this is a fraction. This is a fraction. So if your entire function here will be undefined, then each of the fraction there, okay, the denominator should be equal to 0. Any of them. So just take the first fraction, okay, equate the denominator to 0. Or your second fraction, its denominator, s plus 4, is equal to 0. Here, s is solved for, you come and solve for x here. Okay, minus 4. And your conclusion will be therefore x is equal to 0 or minus what? 4. You get it?
Yes, please.
So just equate, okay, the denominator of each of the fractions to 0 and solve the resultant equation. That's my point. So anytime you have more than a fraction, okay, involved in your function, your relation, this is the approach, okay, to use. All correct?
Yes, please.
All right. So it means going forward, okay, I will be using the alternative, okay, and the ideal approach. Okay, all right. So at this point, I think, okay, let me see. Someone has sent a message. Let me read. Okay, well done. So now you know. That's why the teacher factor is very important. So without the teacher factor, you wouldn't know, okay, what to do, okay, what is right and which one will be costly or not. So please take note, you won't lose any marks. That's a matured way of dealing with it. If you do it and your teacher takes, okay, marks from you, you can, okay, let your teacher hear from your lawyers. And maybe you can hire me as one of your maths lawyers. Okay, I will do it pro bono. Okay, I will do it for free. All right, okay, so that will be it. I think, okay, we have done 1 hour. Let's go for our water break. When we come back, then we'll look at the rest of what's the questions. I believe some of you, you've now moved on. Okay, so that will be it. So let's pause, okay, and go for our water break. Okay, so we have to halt our water break. Okay, let's finish, then later we can go for our water break. So now, what do I, okay, do? We are going to look at that of what the B and C, then we are done. Okay, so let's move on to the next solution slide. So B, okay, so B, what are we giving? B, we extract what we are giving. So we've been giving this function, didn't come with a name. This relation didn't come with a name. So it is x over, okay, s plus 1, okay, then plus what? 2 minus x over, okay, s minus 3. Okay, so please take notes. This is what we have. Okay, great. Okay, so now, obviously, we are dealing with an expression or a function that contains more than a fraction, more than a term. Okay, so don't worry at all. It's the same approach. So in this case, what do? I will go and write for undefined, oh, sorry, not defined. Okay. Set each of the denominator to 0. So x plus 1 should be equal to 0, or, okay, x minus 3 should be equal to 0. All correct?
Yes, please.
Okay, because if you go and take the denominator, the LCM, which later you equate to 0, the LCM will be the same as S plus 1 in brackets, S minus 3 in brackets. So it's not necessary, you know, from the beginning what you equate to 0. So this implies that X is equal to what? Minus 1, or, okay, X, okay, is equal to 3. You can see that here, because I'm not solving under 8, okay, I wrote the or again because now something has interfered with the or. I'm not solving under 8. So I want to be consistent. Anytime you move from one line to the next line, you write close to the margin. So at this point, you can draw your conclusion. Therefore, X is equal to minus 1 or 3. All correct?
Yes, please.
Okay, then the last one, C. Okay, I think you will guide me. It will be a little involving. Okay, but no problem. You should be able to do it. Given, okay, what do we have? G of X, okay, is equal to X plus 1 over 2X, okay, then plus 2X over what? 9 minus X squared. So let's see. For not defined, okay, my denominators, which is 2X, okay, should be equal to 0, or, okay, which other one? I will push this one to the side, so don't worry. So I will write through the line, but I will later deal with it. But you are not supposed to do that. Assuming if there's a situation, you will calm down. Okay, so let me calm down so that you equally learn from that. Okay, so 9 minus what? X squared is equal to 0. So now you come and solve for X in each of the equations that you have set. So now getting my X there, that will give me, this implies that 2X is equal to 0. I write it again before I divide 2. Okay, so that will give me X is equal to 0 here, because 0 over any number is 0. Or, okay, then the second one will come in, which is the 9 minus S squared. And you can see that what type of equation have we formed here? Can we see here?
Difference of two squares.
No, what type of equation? I didn't say, okay, what type of expression?
Linear equation.
Are you sure it's linear? Linear, the power must be 1. The highest power of the variable here is what? It's quadratic. Okay, so once it's quadratic, you ask yourself, how do I? So every step on the way, ask yourself questions. And once you are able to get answers to these questions, it will make your work very easy. Okay, so it's a quadratic equation. How do I solve quadratic equation? Okay, if it's factorable, I factorize. Okay, otherwise, I have to use the quadratic formula. Okay, so at this point, okay, so Caleb, you are right. So I ask myself, how do I solve this quadratic equation? And I can solve by factorization, because this is difference of two squares. So this will give me 3 squared minus S squared. So if I factorize, that will give me 3. Oops. Okay, let me go back. 3, okay, plus X, then into 3 minus X as my factors being equal to 0. Is my point well made?
Yes.
Or, okay, maybe someone wants me to come again. Those who are always waiting for
Please
this
come
question.
again.
Ah, you see? All right. Okay, so now, okay, so indirectly, let me see. Okay, let me pause then, do this. Let's see if you can relate. Oh, so it means all along I wasn't recording.
Yes,
Really?
please.
Oh, you didn't prompt me, you people. Wow, so all that I said, where did I even end?
So on my screen, it shows it's still recording.
It's not recording. No, it's now that I was stopping. I was more or less stopping recording. Then I pressed and I realized that it told me I have resumed recording, meaning I wasn't recording initially. So it's now that I'm recording. Okay. Meanwhile, my intention was to pause, okay, or stop recording. So let me see if I can quickly go, but I don't even know where I ended. Okay, where I stopped what's recording. Okay, so in any case,
Sir,
okay,
please,
so
you stopped when you went off to explain. You explained the E.
the C. Did you get did you say the C?
Yes.
Okay, so you
No,
mean
you
Yes.
stopped when
When you were re-explaining, yes.
you come to explain the plus of
the plus or minus. Okay, so I think maybe the point is well made. Okay, there. Okay, so if that's the case, then it means you didn't miss anything much. Okay, I've told you, anytime you are taking the square root, ask yourself that vital question. Quantity, is this really positive? Is this really negative? If you don't have enough information to say that it's really positive, it's really negative, then you have to attach plus or minus to the other side, not or to the side that's the quantity that you, so not plus or minus shouldn't be here. Okay, this is where you are making the variable that you are making the subject. So the plus or minus should be at the other side where, okay, it doesn't contain the variable that you are making the subject. Take notes. Okay, and that gives us this, okay, what we have there. So at this point, like I said, this becomes your class assignment. You will do it and you submit it. I will give you the deadline. Everyone must take part. Okay, you submit before you leave. You must submit before you leave. Please take notes. Unless maybe you think you have to watch the video again to better understand. In that case, you seek permission on your platform, the assignment submission platform that you've created. Then, okay, you can watch and submit later. Okay, thank you. But when you are seeking permission, seek permission with your own deadline and with an explanation. Or I think, yes, I mean, a reason for that permission. Okay, but it should come with your own deadline so that if you don't meet your deadline, then I know it's intentional. Okay, you have decided not to do the work. So thank you very much for your contribution and making this class a success once again. God bless us all.